Ladies and gentlemen, we're back with another video. My name is Mr. Jackson. In the previous two lessons, we talked about one-step inequalities and two-step inequalities, and those are going to be linked in the description for you in case you want to check those out. But now we're going to bump it up just a little bit more to multi-step inequalities. We're still going to have variables on one side of the inequality symbol, but now we're going to see things like distributive property and combining like terms. So with that being said, let's get into the lesson. A tangled mess of knots I confess, but the intent was there. I swear he set our sights on something that we... Now, for multi-step inequalities, it's absolutely no different compared to one-step and two-step inequalities. The end goal, no matter what, is to isolate the variable and get it by itself. Multi-step inequalities just means we have a few more steps we have to get through before we actually get to the final answer. So that's where we now have to look for a distributive property and combining like terms. Sometimes there might be both in one problem. There might just be distributive property. There might be combining like terms. It just depends on the problem that you get. So let's go ahead and jump into number one, see what we're looking at. And then I have a few different examples to show you on here as well. And then we'll dive over to some practice problems in a little bit. So for number one, we have 3 on the outside of parentheses. I see an x plus 4 on the inside of parentheses plus 2x minus 5 is less than or equal to 27. So I always have my students draw a line right down where that inequality symbol is to separate the left side and the right side of the problem. Because whatever you do to one side of the problem, you're going to end up having to do the other side of the problem when we get to inverse operations. So first let's check to see, can you simplify anything that's inside the parentheses? So I see an x and a plus 4. These are not like terms. The one is a variable with the letter x with it, and the other one's just a constant, which is a number all by itself. You can't combine them together unless they have the same variable raised to the same power, or if they're just constants or plain old numbers. Like if it was 8 plus 4, we could obviously add those together. But since one has the variable x and the other one's just a constant or a plain old number, we can't combine those together. So the next thing I look to see is, well, is there any distributive property? And there is. We have a number directly next to the parentheses, which is at 3, and we can distribute it to every term that's on the inside of parentheses. So 3 times x is going to be 3x. 3 times a positive 4 is going to be plus 12. And then I'm going to bring down everything else that we haven't used yet. You don't want to jump hoops and go, add 5 things in a row and just try to do it as quick as possible. I know students that know this like the back of their hand. The only issue is that they go so fast that they end up making simple mistakes on inequality problems. And then we can bring down the less than or equal to and the 27. Now that distributive property has removed the parentheses, we then want to check to see, well, can you combine anything, or do we have like terms? And I see 2 pairs of like terms on the left side here. We have a 3x and a positive 2x. Those are like terms. They have the variable x in common, and they're both raised to the same power. So like, for example, if one was 3x and the other one was 2x squared, those are not like terms anymore. So we can combine these. And then we have another pair of like terms that we can combine together, which is a plus 12 and a minus 5. Those are constants or plain old numbers, which means we can combine them together. So 3x plus 2x is going to be 5x. Positive 12 minus 5, that's going to be plus 7, is less than or equal to 27. Notice how we haven't done anything to the right side yet because we first had to simplify everything. We checked distributive property, we combined like terms, and now we're going to tackle isolating the variable now, which involves inverse operations. So you always want to get rid of the number that doesn't have the variable next to it, and 99.9% of the time, it's the number that's being added or subtracted. So we have plus 7. Well, the only way to remove adding by 7 is to subtract 7 on both sides. So below our plus 7, we're going to do minus 7. Which means we're going to have to do it on the other side of the line as well. So again, whatever you do to one side, you have to do the other side as well. So plus 7, minus 7, those are inverses or opposites. Those cancel. And we're left with 5x is less than or equal to 20. Now we're close to getting x by itself. It's currently being multiplied by 5. Well, the only way to get rid of multiplying by 5 is to do the opposite or the inverse and divide both sides by 5. So I'll draw that line again. Divide by 5, divide by 5. 5 divided by 5 is 1, which these are just going to cancel. 1 times x is just x, meaning we isolated it, is less than or equal to 4. And then we have our final answer. Our final answer is x is less than or equal to 4. And then I just want to show you how to graph it. I showed you in the one-step and two-step inequality videos if you've seen those. If not, I'll jot these down here again for you. If you have a greater than or less than symbol, you have to use an open circle. But if you have greater than or equal to or less than or equal to, you need to have a closed circle. So for this one, we have less than or equal to, which means we're going to have a closed circle on the number 4. And our inequality symbol is pointing to the left. So if I drew this out down here, it kind of looks like the tip of an arrow. So if I was to make this into an arrow, it's pointing to the left, meaning that we're going to draw a line going from our closed circle all the way down the number line to showcase all of the solutions that make this inequality true. So like if I pick, for example, -12, that's on that line. If I plug that in for the variable, -12 is less than or equal to 4, well, that inequality is true. And for a closed circle, what that means is that if I use that number that's on that closed circle, in this case 4, and I plug it in to my inequality, it's also going to make the inequality true. So a closed circle means that that number is part of the solutions that make the inequality accurate, right? I know that was a lot of explanation for the first one. The other two will go a lot quicker than that, but now you kind of have the rundown in case you didn't watch the 1-step and 2-step inequality videos. So let's go ahead and dive over to number 2 now. We have -20 is less than, and then I set this problem up like this because I've seen this and I've given this to students before and they're like, whoa, what happened? Okay, it's set up like a fraction here and it kind of confuses them at first, but it's really not that bad. So let's go ahead and draw a line separating the left and the right side. In this one, we want to approach a little bit differently. First, I'm going to check to see, can you distribute, can you combine like terms or anything? And I notice that you can't do anything right now. First off, I don't see parentheses, so we're not distributing for sure. Combining like terms, we can't do anything yet. So we're going to move on to starting to isolate the variable, because you can have multi-step problems without distributing or combining like terms at all. So for this one, we want to get rid of the number that doesn't have the variable. In this case, it is subtracting by 15. So let's go ahead and add 15 to both sides. So plus 15 over here. Inverses are going to cancel on the right side. -20 plus 15 is -5 is less than -w plus 14 in the numerator. And then we have 7 in the denominator. And now we've eliminated that 15 entirely, which means we're one step closer to being done. Now let's go ahead and get rid of the denominator. In this case, it is a 7, but don't forget that it's negative. So to get rid of dividing by -7, we want to multiply both sides by -7. And notice how we're getting rid of the number that's the furthest away from the variable. When it's set up like a big fraction like this, I'm always going to get rid of the denominator because the variable is not attached with it. It's up in the numerator. So these are going to cancel. The 7s are going to cancel. We have -7 times -5, which turns to a positive 35. But remember your inequality rules. If you multiply or divide both sides by a negative number, in this case we just multiplied by -7 on the left and the right side of the line, our inequality sign needs to flip directions. So instead of it being less than, this is going to be greater than, and then we're left with w plus 14. And then I'm just going to rewrite it over here. 35 is greater than w plus 14. And then we're down to just one final step, which means we are going to subtract 14 on both sides. So we end up getting 21 is greater than w. And you're going to see that I left a note here down at the bottom because students will get all the way down to the end and the variable's on the right side. But when they graph it and use that little trick with the arrow, they end up getting it incorrect. So I always have students move the variable to the left side, which I'm going to put w over here, and 21 over on the right. The only problem is you can't just make that switch without something happening. The greater than symbol is going to flip. So that's the second reason that the inequality sign can flip. You multiply or divide by a negative number, or if you're moving something from one side to the other, well, something else has to change, which is the inequality sign. So our final answer is going to be w is less than 21. So we're going to have an open circle on 21, and it is pointing to the left, meaning we're going to draw a line all the way down the left side of the number line, meaning that these are all of these solutions that make the inequality true. And remember, if it's an open circle and you plug it into your inequality, it's not going to make this true. So if I plugged in 21 is less than 21, well, that's an inaccurate statement, meaning it's an open circle and that number's not part of the solution set. Now let's go ahead and take a look at the last one before I give you 3 problems to try out on your own. So let's go ahead and draw our line once again. I want to check what's in parentheses first if I can combine them, and I can. 9r plus 3r, those are like terms, so we can add them together. So let's go ahead and do that first. So I'm going to rewrite everything the exact same. 21 is greater than or equal to negative 11 plus 1/3, and 9r plus 3r is going to be 12r. So we simplified that. We still can do distributive property. There's a 1/3 on the outside of parentheses, so let's distribute that to 12r, and then we'll leave everything else the exact same. So 21 is greater than or equal to negative 11 plus 1/3 times 12 is going to be 4r. And now we can go ahead and check to see, well, can we combine any like terms? Well, negative 11 and 4r are not like terms. So now we're moving on to step 2, isolating the variable. So let's go ahead and get rid of negative 11 that doesn't have the variable attached to it. So we can add 11 to both sides. So plus 11 plus 11. 21 plus 11 is going to be 32. I'm just going to write it over here. Is greater than or equal to 4r. And then we can isolate r by dividing both sides by 4. 32 divided by 4 is 8. Is greater than or equal to 4 divided by 4 is 1. 1 times anything, we're going to be left with just r. And then we have that scenario where we want the variable to go to the left side. So let's go ahead and do that. But remember, our inequality sign is going to flip when we do that. You can't just make that change without something else happening. And now if we graph this, we have a closed circle on 8. And it's going to be going to the left. And these are going to be all of our correct solutions for number 3. So now let's go ahead and give you 3 practice problems to try out on your own in the practice session. A little bit longer lesson than the previous 2 videos, but again, we're kind of bumping it up a notch. So every time it's just going to take a little bit longer, which is fine. I'd rather give you a thorough explanation than kind of really only show you one example and then, you know, I guess you fend for yourself at that point. So this is the practice session. I encourage you to pause the video, write these 3 problems out, and try them out on your own. See if you can go from start to finish and even graph it yourself on the number line, and then come back and play the video and see if you went 3 for 3. So I'm assuming at this point you've paused the video, you've tried out these 3 and are ready to go over the answers. So let's go ahead and move into number 1. So I'm going to draw that line separating the left and the right side. And I notice right away that we have distributive property. You can't combine what's in parentheses. Those aren't like terms. So we have no choice but to distribute this negative 5 here. So I'm going to leave everything else the exact same. We have 40 is greater than negative 10x minus 20. And then I'm going to bring down that minus 10. Then after that, distributive property is done. But I do see that we can combine like terms here. We have a negative 20 and a negative 10 that are just constants or numbers all by themselves without a variable, anything like that, that can be combined together. So I'm going to leave 40 alone, the greater than symbol, the negative 10x, and negative 20 minus 10 is going to be a minus 30. And now that we've done step 1, we simplified both sides to the best of our ability. Now our goal is to isolate the variable and get it by itself. So we're going to add 30 to both sides, because that's the one that's the furthest from the variable. So add 30. Cancels, cancels, and over here we're going to have 70 is greater than negative 10x. We'll draw that line again. And then to get x by itself, we want to divide both sides by negative 10. The negative 10s are going to cancel, but keep in mind we just divided by a negative number. So 70 divided by negative 10 is negative 7. Our sign needs to flip because we just divided by negative. And we have x over here by itself. And then we have another rule that we have to utilize in the same problem is we want to move x to the left, negative 7 to the right, and flip the sign. So the final answer for number 1 should be x is greater than negative 7. So this is going to be an open circle on negative 7, and our inequality symbol is pointing to the right. So this is going to be all of our solutions except for the one that's in the open circle, because again, that doesn't satisfy your inequality. Now, if you got number 1 right, very, very nice job. And let's go ahead and dive over to number 2. Again, let's draw that line separating the left and the right side. I see combining like terms in parentheses right away. 3r plus 4r can be added together, so we'll leave everything else the exact same. 3r plus 4r is 7r. Again, not doing too many steps in one, just one thing at a time. Now we can distribute the negative 5 to the 7r, so this is going to be 16r minus 35r minus 11 is less than or equal to 27. And then we can combine like terms here. So we have 16r and a minus 35r that are like terms because they are both the same variable raised to the same power. It's not like r and then r squared. And then everything else is going to stay the exact same. So we are going to have for this negative 19r minus 11 is less than or equal to 27. And then I'm just going to write it down here. I don't want to cut into the webcam or ruin the number line. So I'll just erase it at the end here. So negative 19r minus 11 is less than or equal to 27. We'll draw that line. Let's add 11 to both sides now because we're trying to isolate the variable at this point. Cancel those out. We have negative 19r is less than or equal to 38. And then finally, let's go ahead and divide both sides by negative 19. This cancels, and we're left with r negative 2 over here, but we just divided by a negative number, meaning the sign needs to flip, and we get r is greater than or equal to negative 2. So we have a closed circle on negative 2, and this is going to be going to the right because our inequality symbol is pointing to the right for our final answer. So all I'm going to do is write what the final answer was here, and then I'm going to erase all of that work. You can always pause the video and see what I did there, right, in case you got number 2 wrong, just so we have space for number 3. So let's go ahead and draw a line for number 3. We want to get rid of that minus 6 first. So let's go ahead and add 6 to both sides. We don't have distributive property or like terms or anything like that. And we have negative s plus 12 over 3 is less than or equal to negative 12. We're going to multiply both sides by negative 3 to get rid of that denominator and that negative sign. So those are going to cancel. And we multiply over here. It's going to be a positive 36. So we're left with s plus 12. Sign flips because we multiplied by a negative. And then positive 36. We draw our line. And then finally we can subtract 12 on both sides. So s is going to be greater than or equal to 24. We have a closed circle on 24 and going to the right. Hopefully you went 3 for 3 in the practice problems. If you did, very, very nice job. I hope this video helped you guys out in multi-step inequalities with variables on one side, understanding distributive property, combining like terms, isolating the variable, and then also the graphs for the inequality as well. If the video helped you out, leave a like on the video, comment topics you want to see in the future, and again, subscribe, turn on that bell for post notifications, and we'll see you in the next one with some more mathematics.
It falls apart, there's not